Okay, what you've all been waiting for, I know. We're now going to look at solving these equations using logs as well. There's no way for me to write 10 as 5 to the power of something, so this one looks pretty hard to solve. So let's bring in logs and see how logs can help us solve equations like this. We're going to use the same idea of whatever you do to one side, you do to the other. So I'm going to take log of both sides and let's see what that looks like. So let's do log base 10 of 5 to the x equals log base 10 of 10. Ooh, seeing something kind of nice here on the right hand side. I'm hoping you can see that as well. So log base 10 of 10, we know that that equals 1, which is awesome. But we also know over here I've got a power. I can take that power out the front, can't I? So let's do that. So I've got x log 10 of 5. Okay, and if I want to find x, let's get x by itself. So this is really x times this log. So how do we undo times? We divide. So let's divide by log 10 of 5. Whatever you do to one side, you have to do the other. Okay, they're going to cancel out, and my x value is going to be the answer of this, which I will now plug in onto my calculator and get a final answer. So however many decimal places that you need to give. In the worked example, they ask for 3. So our answer is 1.431. So the next type of problem could have an expression in the exponent, and that's fine. I look again at the 12, and there's no way for me to write the number 12 as 2 to the power of something. So I can't use that method that we have used previously. So let's bring in logs. So again, I'm going to take the log 10 of both sides. I'm not going to write log base 10 anymore. I'm just going to write log. So if you see me write log, it is to base 10, unless I write another number in there. It will always be base 10. So let's take the log of both sides. So it'll be log 2 of x plus 1 to the power of x plus 1, and then same on the other side, log of 12. Okay, I have a very similar thing happening here with the power, so I can grab this power and take it out the front using that log rule. So I'm going to have x plus 1, I'm just going to put that in brackets so I don't mix it up. Log of 2 is log of 12. Lovely. Now let's get that x plus 1 by itself. So I'm going to divide by log 2. Whatever you do to one side, do the other. They cancel out, and now I have x plus 1 equals this beast right here, log 12 over log 2. Okay, great. And then I need to get x by itself because that's what I'm trying to find. So how do I get rid of a plus 1? Same as in algebra, we're just going to minus 1 from both sides. So my final answer is going to be the calculator result for this particular expression. So when we plug that in, we should get an answer to 3 decimal places of approximately 2.585. And that's how you solve that type of question. So hopefully that's okay, and that will enable you to get further along in exercise 3C.